Hello everyone, welcome to the class where we'll be learning mathematics of grade 10. Let's focus on the chapter where we'll be doing lots of solving of equations. You got it right. It's pair of linear equations. In simple terms, we call it as pole. In this chapter, we will be mainly focusing on first part of that area, graphical representation. So you can see here, graphical representation, any linear equation for that matter of fact, can be written in the form of ax plus by plus c equal to 0. This is how we represent any kind of general equation. And you know how many solutions will it have? This linear equation alone will have infinite solution. And infinite solution it means it will never end. It's going to go on forever. And it's difficult to imagine such scenarios. So let's see this with the help of a graph. So a graphical way of understanding linear equation is much more easier. So this is a graph I have taken here to represent a linear equation. The equation I've chosen here is 2x plus 3y minus y equal to 0. And in this graph, you will see something peculiar. That this graph is passing through the x-axis and passing through the y-axis. And in a way, it's going down. So you can see there are millions, billions, trillions of points. Because it's a line segment, it will go on forever, continuously on both the ends. It does not have any end points. So all the points in this, it could be decimal, fractional, negative, all of them that satisfy any points, any coordinates which satisfy the conditions of this equation will be called as solution of this. Technically speaking, even this point over here, you can think of it, where the x coordinate happens to be minus 5 and y coordinate happens to be 5, will satisfy this equation. Let's check it out for sure. 2 times minus 5 plus 3 times 5 minus 5 is equal to 0. Now we're going to verify if it happens to be or not. 2 times minus 5 is negative 10. 3 times 5 is 15. Minus 5 is equal to 0, which happens to be 15 minus 15 is 0. So you're getting 0 is equal to 0. So hence we verified that all the points of this lying on this line, it could be decimal, fractional, not a problem at all. So how will we solve the equations of such type? We just cannot. Because if they ask you to solve, well, you can just pick any value for x. I can pick the value of x as 1 or x as 2 and get the value of y for it. But these are not going to be actual solution. They are just a solution of it. To solve such equation with two variables, you will need two different equations. Okay, so two different equations will help us make another graph, which will in return give a common solution, which is going to be the answer. Now, that's not always the case. Let's see scenarios where we will understand this more detailedly. Let's take one scenario. So here we are having to solve graphical method of solving the linear equation. So I've taken two different equations over here. First equation you can see in front of you, equation number one. 2x plus 3y minus 5 equal to 0. Second equation I have made up there, x plus y minus 2 is equal to 0. Now, both of them, when I plot them independently, I end up getting this line 1 and line 2. Now, what you need to understand is, independently, if I solve them, I will get one line in each. It's very unique. So this graph has a unique equation. So is this as well. Unique equation. And every equation will have a unique graph. Now, both of them are it's like your encrypted value. They are never going to change. It's always going to be in the same line. All the solutions of this equation will lie on this line. Same thing goes with the other one. Now, wherever the common intersection point is, where both of them are passing through, that point is called as the common solution, or in just simple terms, the solution. In this case, they're intersecting only at one point, and in a graph, in a plane, it can only intersect at maximum once. So that is why we say that this is intersecting lines. Okay. Sometimes we might get some lines which are not going to intersect. You might see them just parallel to one another. Such scenarios are also possible. But for now, we will just try to figure out whether the lines will intersect or not. But plotting a graph itself, each of them in the graph sheet is actually a time-consuming process. It's not something we can talk about it and get the answer in a minute's time. It will take at least 5 to 10 minutes to do two graphs as a whole. So we have a simpler method which is going to help us figure out how will the graphs look like? What kind of solutions will it contain? Let's have a look on that. So here, the possible scenarios when you're having two lines or two equations plotted, it could be either intersecting lines, the one which we saw right now, or they could be parallel lines where they are going to be exact same distance throughout. They will never come close, they will never go far. Such lines are called parallel lines, and these are lines of two different equations. So this is what is going to be when you have no solution. There are some equations which will we cannot just solve it all. And depending upon the equation, there are some conditions which we're going to look across and then come to conclusion without plotting. Okay. But if at all you have two equations, they could either have one solution, intersecting point, or they could have no solution. This is one solution. This is no solution. And the third one is the most interesting of all because they are coinciding lines. And coinciding lines technically are overlapping at each and every point. So you have two lines which are completely overlapping each other and looks like it's one line, but actually it's two different lines. Now this is what has infinite solution again. So infinite solution is only possible when two lines are completely overlapping. And this is possible when you are having a condition. So we're going to look at the condition, what makes the lines intersecting or parallel or coinciding. Let's have a look at that. So this is the general form of writing the equation, as you know, ax plus by plus c. But as we're dealing with two different lines, I'm going to take it as a1, b1, and c1 for the first equation, a2, b2, and c2 for the second equation. And now, based upon this, we want to figure out whether the equations we will be solving, will they happen to be having solutions or not? Will they happen to be parallel or will it happen to be overlapping, coinciding? What we do is we look out for the coefficients. So A1 over here is coefficient of x in the first equation. B1 is the coefficient of y in the first equation, and C1 is the constant term of the first equation. Similarly, we have A2, B2, and C2. So these values are what we will look out for in the equation. And once we figure those values out, we'll try to check whether they happen to have any of the conditions met. If at all the conditions of this are met, for example, I've taken the equation over here, 2x minus y is equal to 3, and 3x plus 2y minus 4 is equal to 0. First thing, always you have to make sure you write it in standard form because it gets more easier. The standard form says that right-hand side should be having 0. So we'll make sure we write in standard form. And by doing so, we get the value of A1 as 2, okay, and B1 as minus 1, and C1 as negative 3. And same way, A2 value is 3, and B2 value is 2, and C2 values minus 4. So we just substitute the values in actual. So we'll put the values over here, 2 by 3, okay, and whether it's equal to minus 1 by 2. Technically, they're not equal because clearly the denominators are different, the signs are different. So this condition is what we're looking across where the signs and the values are not equal at all. So the condition we're looking for is A1 by A2 is not equal to A1 by A2 is not equal to B1 by B2. This is not being met. Hence, the given line will be intersecting. This condition is what we are seeing across. They are not going to be equal. Hence, they're going to be intersecting lines. Second scenario, when you're having the A1 by A2 coordinate coefficients equal to B1 by B2 coefficients, but not equal to C1 by C2 coefficients. This is possible when the equations given to you and the coefficients are having the conditions met over here. The coefficients of A1, A2 is equal to B1 by B2, but it's not equal to C1 by C2. But if this condition is met, it will help us figure out that the lines will be parallel lines. That means it will have no solution. And in the case of intersecting lines, it will have unique, obviously, unique is itself understood as one. So unique solution. And last scenario, where all the three of the ratios are equal, A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then we see that you can see this 1 by 2, 2 by 4, minus 3 by minus 6. If all of them are equal, they give us the same ratio, then we can see that the given lines are having the ratio A1 by A2, which is equal to B1 by B2, which is equal to C1 by C2. Hence, these lines are coinciding lines. It means they have infinite solutions. So based upon these conditions, we can tell whether the given line segments or given the given line or the equations, will they be having solutions or not? Will they have a unique solution or will they have infinite solution? So without plotting the graph, this conditions will help us filter out or get us clarity about the graph. How will they look? How many solutions can they have? And with this, the actual linear equation chapter is started. And the question can be straightforward like this, whether to check if it's going to be what type of lines, or sometimes they'll ask you that given the lines are intersecting, find the unknown value of the missing term. So you'll have to use this vice versa as well. So the basics of this are very important. So in coming video, we'll be discussing and doing problems where applications of this are happening. We'll apply the knowledge of these questions and then solve some questions of it. All right. Okay.